On May 22nd, 2026, the most powerful rocket ever built lifted off from a brand new launch pad in South Texas. And what happened over the next 65 minutes was a masterclass in how SpaceX approaches aerospace engineering. Thrilling successes, real failures, and a program that keeps moving forward no matter what. This is the full, unfiltered story of Starship Flight 12 and what it really means for the future of space travel. Like and subscribe. Before we get to what happened on launch day, you need to understand why Flight 12 was different from every Starship mission that came before it. This was not just another test of a familiar rocket. Flight 12 marked the world debut of Starship version 3, a completely redesigned vehicle that represents such a dramatic leap in capability that engineers essentially drew a new rocket from scratch. And it launched from Pad 2 at Starbase, a brand new launch complex that SpaceX spent 2 full years constructing specifically for this generation of the vehicle. Everything about May 22nd was a first. Starship V3 stands 408 feet tall when fully stacked, roughly 5 feet taller than its V2 predecessor. But the physical size difference is almost irrelevant compared to what changed under the hood. The payload capacity upgrade alone is staggering. V3 can carry over 100 metric tons to orbit. V2 could carry roughly 35 metric tons. That is nearly 3 times the payload capacity in a single generation jump. No other rocket program in history has achieved that kind of performance increase between versions. Like and subscribe. The engine powering this leap is the Raptor 3. SpaceX completely redesigned its main engine for V3, making it more powerful, lighter, and simpler than anything the company has built before. Raptor 3 eliminates the external engine heat shield that previous versions required, reducing mass and mechanical complexity simultaneously. The entire first stage booster runs 33 of these engines, and SpaceX redesigned a fuel transfer tube, a component roughly the size of a Falcon 9 first stage, specifically to enable faster and more reliable simultaneous startup of all 33 engines at once. The booster also went from 4 grid fins down to 3, but each new fin is 50% larger and significantly stronger than its predecessor. The upper stage received an equally comprehensive overhaul. Starship V3's ship features a completely redesigned propulsion system, a simplified aft section with fewer shrouds, and a brand new single actuator flap system with 3 motors PES, or flap for dramatically improved redundancy. Most importantly for SpaceX's long-term mission, drogues and dedicated propellant transfer connections for ship-to-ship operations in space. Orbital refueling is the key technology that unlocks Starship's ability to reach the Moon and Mars, so including it in V3 is a major strategic milestone even before the vehicle flies. Like and subscribe. Now let's talk about what actually happened on launch day, because getting to liftoff on May 22nd was itself a story. SpaceX attempted the launch on May 21st and scrubbed it. The automated countdown sequencer kept tripping holds due to a problem with a propellant line attached to the Starship spacecraft, a sensor issue on the rocket tower, and a problem with the water deluge system. These issues pushed the attempt to the following day. On May 22nd, after working through the technical issues, Booster 19 and Ship 39 lifted off together at 5:30 p.m. local time, 22:30 UTC from Pad 2. For the first 2 minutes and 20 seconds, Flight 12 was essentially flawless. All 33. Raptor 3 engines fired at liftoff, and SpaceX officially confirmed post-flight that 32 OF the 33 completed the full ascent burn. Only a single Raptor shut down early during the climb, and it did not affect the vehicle's trajectory. For context, V2 flights struggled with multiple engine outs during ascent. Flying 32 out of 33 engines through a successful first stage burn is a genuinely impressive result for a vehicle's debut flight. Like and subscribe. Hot staging occurred at the 2-minute and 20-second mark. Hot staging is the maneuver where ship begins firing its engines before fully separating from Super Heavy, allowing the upper stage to gain thrust immediately rather than waiting through a coast phase. V3 implemented an important upgrade here. Unlike V2, which used a disposable inner stage ring that fell away at separation, V3 integrates hot staging hardware directly into the booster structure. This means no disposable components, lower cost per flight, and one fewer thing that can fail or create debris. The separation itself went smoothly. Then the booster's problems began. After stage separation, Super Heavy needed to flip and execute its boost back burn, the critical engine firing that redirects the booster back toward its landing zone in the Gulf of Mexico. Out of 13 center engines, the broadcast confirmed 12 ignited for boost back. But as the outer ring engines tried to come back online, multiple engines were shown as out. The boost back burn started, then ended prematurely. Booster 19 began tumbling. Like and subscribe. SpaceX's on-air commentator Dan Hute said live during the broadcast, "It looks like we just had an early boost back shutdown." The flight termination system, The safety mechanism that would destroy the rocket if it threatened public safety was intentionally left inactive, allowing the booster to continue on its natural trajectory. Booster 19 partially recovered from its tumble and attempted a landing burn on the way down. Only one of the 13 landing engines successfully ignited. The result was what T engineers call a transonic impact, a hard, uncontrolled splashdown in the Gulf of Mexico. The booster was lost. Now, here is where the Flight 12 story becomes genuinely remarkable. Because while the booster was failing, Ship 39 was quietly doing something extraordinary. Like and subscribe. When the upper stage separated, all 6 of its Raptor engines, 3 sea level and 3 vacuum optimized, ignited successfully. One of the vacuum Raptor engines failed shortly after ignition. But here is what separates SpaceX's engineering from every other aerospace organization on the planet. The flight computer recognized the engine failure instantly, gimbaled the remaining engines to compensate for the lost thrust vector, and extended the burn duration to put Ship 39 precisely on its planned suborbital trajectory. The vehicle hit its target despite flying with 5 engines instead of 6. Most rocket programs would have called this a mission failure. SpaceX's autonomous flight computer turned it into a successful ascent. Ship 39 then entered its coast phase in space, and this is where Flight 12 separated itself from every previous Starship mission with a payload demonstration that the space industry has been waiting years to see. SpaceX deployed 22 objects from the updated payload bay using what the company calls a Pease dispenser mechanism, a narrow slit in the spacecraft's body that ejects flat satellite panels one by one. Like and subscribe. The payload consisted of 20 Starlink mass simulators sized and shaped like next-generation V3 Starlink units, the actual satellites that Starship will eventually launch in bulk once it reaches orbital capability. The final 2 payloads were something even more interesting. SpaceX deployed 2 modified satellites nicknamed Dodger Dogs, technology demonstrators for future V3 Starlink components, each equipped with external cameras and lighting systems. After deployment, the Dodger Dogs activated their lights and turned their cameras towards Ship 39 in space. They photographed the vehicle's heat shield from orbit and transmitted that imagery back to operators on the ground. The crowd at SpaceX's viewing area erupted when those images came through. That photograph of Starship's heat shield taken from orbit is not just a cool image. It represents the foundation of a rapid inspection system that SpaceX needs to achieve the flight cadence they are targeting. If every Starship flight requires days of hands-on human inspection of thousands of heat shield tiles, the economics of reusability break down. Automated orbital inspection changes that equation entirely. Like and subscribe. SpaceX made one significant real-time decision during the coast phase. Based on the engine anomalies during ascent, the team decided to forego the planned in-space Raptor engine relight experiment. That was the right call. Conserve objectives when the vehicle has already encountered anomalies. Do not add risk unnecessarily. The engine relight test will be a priority for Flight 13. Reentry was where the upgraded heat shield got its first real test, and Elon Musk confirmed post-flight that V3's heat shield held well through the plasma environment. SpaceX intentionally removed one heat shield tile before the flight to measure what happens to adjacent tiles when a gap exists, critical data for understanding failure modes and refining tile placement patterns. Several tiles were painted white to serve as imaging targets during reentry. The vehicle also performed a dynamic banking maneuver designed to simulate the trajectory that future return-to-launch site missions will fly when Starship eventually comes back to Starbase for landing. Like and subscribe. Australia. Exactly where it was planned to land. From the moment of launch to the moment Ship 39 hit the water, the upper stage performed its mission with the kind of precision that made even skeptical observers take notice. Elon Musk called Flight 12 epic in his post-flight response. That characterization is defensible. Consider what actually happened. The most powerful rocket ever built flew for the first time from a brand new launch pad. It carried 33 next-generation engines through a successful ascent. It demonstrated hot staging with an integrated design that eliminates disposable hardware. It reached space with a 5-engine upper stage, despite losing 1 engine during ascent. It deployed 22 satellites using a new dispenser mechanism. It returned orbital heat shield inspection imagery. It survived re-entry and executed a controlled splashdown on target. Like and subscribe. The booster failure is real and consequential. The FAA classified Flight 12 as a mishap. But calling Flight 12 a failure because the booster crashed misses the larger engineering picture. SpaceX has now proven that V3's upper stage works. The new pad works. The Raptor 3 engines work through ascent to survive a re-entry experiment that intentionally induced additional stress. Let's zoom out to understand what V3 actually means for the entire space industry. Generation Starlink V3 satellites in a single mission becomes achievable Delivering the lunar landers that NASA needs for Artemis becomes straightforward rather than a logistical puzzle. Building a long-duration Mars mission architecture becomes an engineering problem rather than a physics impossibility. Like and subscribe. SpaceX filed its IPO prospectus on May 20th, 2 days before Flight 12, targeting a June 12th NASDAQ listing under the ticker SPCX at a valuation of up to $1.75 trillion. That prospectus explicitly states that SpaceX's growth strategy depends on increasing Starship's launch cadence and payload capacity. Flight 12 just proved that the payload capacity is real. The cadence question, how quickly SpaceX can solve the Super Heavy booster reliability problem and return to flight, is now the defining challenge of 2026 for the program. Flight 13 is planned to use Booster 20 and Ship 40, a second pair of V3 vehicles. Analysts estimate a July to August launch window depending on how long the mishap. Proven. The catch, using the tower's mechanical arms, will come once the booster can consistently execute its boost back and landing burn sequences. Like and subscribe. What you witnessed on May 22nd, 2026 was not a perfect flight. It was something more valuable than a perfect flight. It was a real engineering test that produced real data about what works and what does. Not on the most ambitious rocket program in history. The upper stage is proven. The pad is proven. The engines are largely proven. The one remaining piece, a super heavy booster that can reliably execute its full mission, is the target of every engineer at SpaceX right now. Starship V3 just launched. Here is what really happened. Most of it worked. The part that did not give SpaceX exactly the data it needed to fix the problem, and the future of spaceflight just moved meaningfully forward. Like and subscribe. Here's one more detail that most coverage of Flight 12 completely overlooked. The fact that SpaceX used its own satellite internet service to stream real-time video of Starship flying through space is a perfect loop of technological self-reference. One system proving itself while simultaneously enabling the broadcast of the other system proving itself. And one final number that deserves to sit with you after everything you just heard. Starship V3 can carry over 100 metric tons to orbit fully reusable. The Saturn V, the rocket that carried humans to the moon in 1969, could carry about 130 metric tons to low Earth orbit, but it was entirely expendable. Every Saturn V that flew was destroyed in the process. Starship V3 is designed to carry comparable mass to, or that is the difference between the Apollo era and what SpaceX is trying to build. And on May 26, 2026, the upper stage of that vision worked exactly as designed. Like and subscribe. There is a generation of engineers, students, and space enthusiasts who have grown up watching Starship go from an exploding prototype in 2023 to a vehicle that is now routinely reaching space, deploying satellites, surviving reentry, and landing in the ocean on command. For those people, Flight 12 was not just a test. It was confirmation that the program is real, the technology works, and the mission is achievable. The booster will be fixed. The investigation will conclude. Flight 13 will fly. And each flight after that will bring Starship closer to the moment. It changes everything. The first fully reusable flight from launch to catch, ready to fly again within days. That day is closer than most people realize. And Flight 12 just proved it. Stay locked in. Like and subscribe. The path from here is clear. Solve the Super Heavy booster engine sequencing problem. Often with real payloads. Version 3 of Starship is the vehicle that does all of that. Flight 12 just gave the world its first real Liu K at what version 3 can do. What it can do is extraordinary. Like and subscribe.